we will. We'll get to an activity instead of just like a worksheet, right? I'd rather do an activity. Okay, so 2.3 is all about solving quadratics. So now that you remember how to factor, that's your first blank there. Now that you remember how to factor, we will take that information and begin solving equations. All right. So does anybody remember why we solve quadratic equations? Does anyone know why we solve quadratic equations? What's the purpose of it? Right, because they make you. Why else? We talked about at the beginning of class today.
Because when you factor, those are
Excellent. Thank you, Brianna. Because when we factor, we are solving to find the x-intercepts. So why do we solve quadratic equations? To find the x-intercepts. That's your blank there. To find the x-intercepts. If you don't know what an x-intercept is, make yourself a note that the x-intercept is where the graph crosses the x-axis. So we have a couple names for them. The first name we said was x-intercepts. What about, do you guys remember what your do now, what the verb or the noun said? What did you say? The zeros. That's what they called them on the paper, was the zeros. Yep, exactly. Roots. They're also called roots. Anybody else know the other name of them? When you solve an equation, you find the what? Solution. Good. So solution, what did you say?
points.
Points. We're going to use solution. Okay.
So if you say to find the zeros of the graph, will be the same thing as finding the
Exactly. If I said find the solutions of the graph, it's the same thing as finding the x-intercepts. All those words are kind of interchangeable. This is a test question, by the way. Name another name for the x-intercepts. This is a test question, by the way. In case you didn't know, this is probably going to be on your next test.
By the way.
Just so you know. All right, got that. Okay, so solving the quadratic is the same process. It is the same process as factoring. We just take it a step further. Okay, so we're going to do the same process as factoring. We just take it a step further. So for some of you, this is review, which is fine. Others of you, this is new. So the standard form of a quadratic equation, let's write that down there. You know what the standard form is. You should by now. What is the standard form of a quadratic equation? F of x is a good way to start it.
Equals ax squared.
There we go.
Plus b plus c.
Okay? We remember this from a few days ago, from yesterday and a few days ago. F of x equals ax squared plus bx plus c. All right, so the first way we're going to solve a quadratic equation, there are a couple different ways we're going to look at. The first way is by factoring. So this is where we're reviewing for our quiz today. Solving equations by factoring. So if I look at the first example, x squared minus 12x equals 0, that means I'm going to be factoring. If it's a binomial, can I split the middle here?
No.
With two terms, are you allowed to split the middle? No, that doesn't work. So how do you factor x squared minus 12x? How do you factor that? Take out the greatest common factor. What is the greatest common factor? X. Okay, if you need to make yourself a note. Number 1, the GCF. So we're going to pull out an x, which leaves me with x minus 12. Today, in our lesson, we have equal signs. So that's what's different about today's lesson, is that now we have equal signs. Beforehand, we didn't have any equal signs. We just factored. So in order for me to find the answer, what I'm going to do is I'm going to split my factors. X is a factor, x minus 12 is a factor. I'm going to split my factors and set each of them equal to 0. So step number 2 would be set equal to 0. So I'm going to set the x factor equal to 0, and I'm setting x minus 12 equal to 0. Brianna, you can move my lid down if it's in your way.
No, it's not.
I can't really do anything with x equals 0, right? It's just x equals 0. That's it. Okay? And what about x minus 12 equals 0? What should I do there? Add 12 to each side? A negative divided by negative is a...
Negative.
No, negative divided by negative is a...
Positive.
Okay.
Just positive.
Go grab your stuff and come back in here. I want you in here for this lesson. Sorry about that. Okay, so we get x to be 12, and we're finished. Okay? That would be it. Our solutions are 0 and 12, and if you want to get fancy, you can write your solutions like this, 0, 12, if you want to get fancy. Those are brackets, not parentheses. Or you can just leave it as x equals 0 and x equals 12. That's fine too. All right, what do we need to do on example 2? Any ideas what we need to do on example 2?
Would you like subtractors for
What would be the purpose of doing that?
so that we can split the middle?
Okay, yeah. We need to get all the terms on the same side, and we need to set it equal to 0. So that's new today. Always set equal to 0. Let's make ourselves a little note here. Always set equal to 0 first. Now, one thing we have to keep in mind is that this term, the quadratic term, always needs to be positive. It always needs to stay positive. So if I were to subtract 3n squared over, it would become negative, right? So instead of moving negative 3 or moving 3n squared over, I need to move the 19n and the negative 6. So how am I going to move negative 6 over? Add 6. How am I going to move positive 19n over? Minus 19n.
So does that have to be a standard form?
Yep, plus 6 and minus 19n. I'm doing all this in one big step. So I have 3n squared minus 19n plus 6 equals 0. Now, if you want to, you can take that a step at a time. That's fine. Okay, I want you to practice factoring this. Okay, I want you to practice factoring this. Multiply to get an 18, add to get a negative 19, negative 18, negative 1. This is our practice for factoring today.
So you don't do anything else, like after you did it over all of them on the same side, then you kind of like drop the equal sign? Equal zero?
For a minute you can if you want to. So the question was, can you drop the equals? We really need to keep the equals on there so I remember what I need to do throughout the whole problem. But if you want to factor it first and then add the equal sign back on, okay, I just don't want you to forget it, okay? Now, maybe some of you put the negative 18 first, but we should get the same answer. The first group, I'm going to pull out an n. The second group, I'm going to pull out a negative 6. So you should be left with 3n minus 1 times n minus 6. Raise your hand if this is what you have to finish factor. 3n minus 1 and n minus 6. Okay, what do we do now with each of these? What's step number 2? Look back at example 1. What's step number 2? set each factor equal to 0.
Oh.
Okay, so I'm going to work it out over here on this side. Set each factor equal to 0. So 3n minus 1 equals 0, and n minus 6 equals 0. Now, in your head, don't just do the opposite. Maybe that's how you were taught, but I don't want you to just do the opposite. That's actually what you are doing, but on a problem like 3n minus 1, you're going to have to do more than just the opposite. Okay, so we're going to have to add 1, then divide by 3. We get n to be 1/3. Add 6, n is 6. What this means is if I were to graph this parabola over here, it would cross my x-axis at 6 and like negative 1/3. That's what this means. That's why we find these x-intercepts. So these answers that you just found, 6 and 1/3, mean that that's where the parabola is crossing the x-axis. Okay? All right. We are going to skip this next. Hang on. Wait. Can you move your hand for a second? All right. On example 5. Quentin, what factors did you choose for number 5? Thank you, Quentin. 10 and negative 2. Now, some of you are splitting the middle, which is fine. You can also take the shortcut and just set up your parentheses since your a value is 1. Yeah, we skipped 4. So I get x to be negative 10. And x is 2. Okay, so we're just taking what we learned with factoring, and we're just taking an extra step, which is setting them equal to 0 and solving them. So again, if I were to graph this parabola, this x squared plus 8x minus 20, if we were to find the vertex and graph it, it would cross the x-axis at negative 10 and at 2. You guys understand how that's working? Okay, let's go on to the next example here. When you cannot x factor, anybody remember how we do this? Nope. When x factoring doesn't work.
You gotta do that, some type of formula.
-b.
Yes. Yep, that big long thing, right?
Square root b minus 4 times a times c.
No.
Close.
Something like that.
Something like that.
Negative b over 2a.
No, that's going to give you the vertex.
I know what you're talking
What
about.
is it like?
Okay, negative b plus or minus, then it's b squared
Negative b.
minus 4 times a.
I love it.
c
Love it.
Over 2.
I'll teach you the song. You want to hear the song?
Yeah, it's not like the song.
Well, it goes to the tune of the Notre Dame fight song. So every time that you sing it, you have to say "Go Irish" at the end. I'm just kidding. You don't have to.
Yeah, you do.
Okay, you do. Okay, so here we go. Watch on the board. You don't have to stare at me. Listen, I don't proclaim that I am on American Idol or anything like that, so just bear with me here. X equals negative b plus or minus square root of. b squared minus 4ac all over 2 times a.
Killed it.
Go Irish! Okay.
Get that on a mixtape.
That's right. All right. Okay, so write this down. Make sure you have it.
Okay.
Negative b, x equals negative b plus or minus square root of b squared minus 4ac all over 2 times a. Go Irish.
Can you say that twice?
Yeah.
I want to.
Okay, one of the things we need to make sure is that when we say negative b, we really mean the opposite of b. Right? So if b is a positive, we're going to make it a negative. If it's a negative, we're going to make it a positive. Notice there is no y. There is no x. I mean, on the other side of the equal sign there is. But all the a, b, and c are going to come from where, do you think? Where do you think a, b, and c are going to come from? From the equation, because remember standard form says ax squared plus bx plus c. This is where you're going to find your a, your b value, and your c value. The quadratic formula does not have any variables inside the formula. So when we plug things in, we're going to be plugging in just numbers. Now, before you hit your calculator up, all right, I want us to write some things down, and we need to clarify some things and get it out of the way. Okay, on the first problem, is it always set equal to 0?
Yes.
Always. Always, always, always make sure it's set equal to 0. In this one, I would like you to write down your a is what? What is our a value here? 9. What is our b value? Negative 12. And our c value? Negative 20. All right. X equals the opposite of b. So my b value is negative 12. So good, Chelsea. I'm going to plug in just a 12. Plus or minus, because remember, quadratic has 2 answers, right? It has 2 points where it's crossing the graph, which is why we're going to use plus or minus. The square root of b squared, so negative 12, and I'm putting the square on the outside, minus 4 times 9 times negative 20. The entire problem is divided by 2 times a, or 2 times 9. So your division bar should stretch the entire problem. Now, before you get going, this is the biggest issue that students have with these types of problems. The biggest issue is finding the sign underneath the square root. First of all, let me remind you that anytime that you square a negative, the answer is going to be what? No matter what your calculator says, the answer is always going to be positive. If your calculator gives you a negative, it means you put it in wrong. All right? Don't tell me, well, my calculator. Don't give me that. All right? Here's the other thing. I hear calculators. Stop punching your buttons. Negative 9, or negative 4 and a negative 20. This sign right here is critical. So what I tell students is determine what the sign should be first. And then when you put the numbers in your calculator, do not put any signs in. Just do 4 times 9 times 20 in your calculator. Because what is a negative times a negative? A positive. That means when you get this b squared, so we have 12 plus or minus 144, we know that this is going to be a plus sign no matter what. Because I determined that a negative times a negative gives me a positive. Now, in your calculator, without any negative signs, just do 4 times 9 times 20. 720. Does anyone else agree with 720?
Yes.
Okay, so plus 720. The whole problem is divided by 18. The entire problem is divided by 18. We don't do division until the very, very, very end. What is 144 plus 720?
864.
Okay. So I have 12 plus or minus the square root of 864, all divided by 18. Now, in your calculator, look at your graphing calculator. I'll show you how to do the square root if you don't know how. you're going to hit second, that blue button, second, and then the x squared key, which is kind of over by the 7. That should pop up a square root symbol on your calculator. Second, then the x squared button. And if you take the square root of 864, what seems to be the issue?
Decimal.
Oh, shoot. I wish Miriam had planned it this way. Oh, wait. She did. Here's what's going to happen. If you came from geometry, you're going to be a rock star at this already. If you came from Algebra 1B, we got a little bit of work to do, but you're going to be fine. We are now in Algebra 2, so we're going to break radicals down. We are not going to use decimals. We are going to break down a radical. This process is probably new to you, so just take a deep breath. You're going to be fine. Off to the side, we're going to break apart 864. There is no one right way to do this. All right, so with your calculator, we know 864 is an even number. Let's try like a 12. Does 864 divide by 12, Kyle? 72? That was a good guess. So we're going to do 12 and 72. I was saying I had a good guess. That's what I said. Now, you can pick 2, like 864 divided by 2 or whatever, and keep going. What makes 12? 6 and 2. What makes 6? 3 and 2. Okay, we're going to leave that for now because we can't break down 2 and 3 anymore. So now let's go over to our 72. What makes 72? 8 and 9. You're going to be using your calculator to help you if you don't know. We know what makes 9. 3 and 3. What makes 8?
4 and 2.
And what makes 4? 2 and 2. Okay. Because there is a hidden little, because there is a hidden 2 right here that you may not know, that's why it's a square root, because there's a hidden 2 there. You're looking for, underneath the little check mark thing, we don't write it, but it means square root. You're looking for groups of 2 things, not the number 2, but 2 things. So let's look at our tree. This is called a factoring tree. I have a group of 3s here. Let's circle them. I have a pair of 2s here. It's okay that they don't come from the same stem because they're still in the same tree. Okay. I have another pair of 2s here, and I'm going to join them. Do I have a pair of anything else?
No.
I don't. I just have this 3 and this 2 left. Would you guys agree with that? That's all I have left? Okay. For every pair, you write it on the outside of the square root 1 time. So I have one group of 2s, another group of 2s, and I have one group of 3s. Does everyone see where that came from? I have a group of 2s here, a group of 2s here, and a group of 3s. What goes inside the square root? Does anyone remember?
3 and 2.
Good, the 3 and the 2, and I'm going to multiply them. So on the outside I have 2 times 2, which is 4, and 4 times 3 is 12. 2 times 3 on the inside is 6. So that was a lot of work. For some of you that was new, that's okay. This radical up here becomes 12 square root of 6. So we're going to write 12 plus or minus 12 square root of 6 all over 18. We will be practicing this skill, so if that was new to you, don't panic. It's fine. Don't forget we still have our x over here. Now, the rule about a radical says that I can reduce whatever's outside the radical as long as there's something here, here, and here that I can reduce by. I never touch the radical. Okay, so even though the radical can be reduced by 6, I don't touch it. I never reduce out of the radical. But can we reduce 12, 12, and 18 by something? What? 6. So let's do that. This is our last step. If I reduce this 12 divided by 6, I get 2. If I reduce this 12 by 6, I get 2. What's 18 divided by 2?
9.
Oh, I'm sorry, by 6. That's what we're doing. 3. This is your final answer. Now, take a deep breath. It's fine. It's fine. You're going to be just fine. Okay? What I would like for us to do is to practice another one. Okay? We're going to practice another one. So, I want you to scratch out example number 4. Okay, so scratch out your example number 4. And I want you to write this problem in instead. If you don't have enough room, take out a piece of paper. Three n squared minus 12n equals negative 7. 3n squared minus 12n equals negative 7. 3n squared minus 12n equals negative 7. Paula, what do we need to do first here?
Set it to 0.
Good. Set it equal to 0, so I'm going to add 7 over. The next step I like to do is to list out what my A, my B, and my C is. Now, I would like for you, please, to write down the equation, the quadratic equation, right here on your paper. I know it's up there, but it's easier if it's right in front of you to know where you're plugging things in at. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I want you to take a minute and plug in your a, b, and c. I'll start working it in just a minute, but I think you can do that part, at least, and then we can simplify the radicals together. I like what I'm seeing. Okay, don't forget your plus or minus there, and then we'll break down 60 together. Okay, so,
I thought you didn't touch the radicals.
well, you don't divide by a radical. You can simplify it, but we won't divide by it. So I think most of us, what I saw in the papers, this is a positive 12. This was 144 minus 84, is that right? Over 6. Okay, so 12 plus or minus the square root of 60 over 6. Raise your hand if you got to this part. Excellent. Excellent. Okay, if you can get to this part, I'm confident. All right? Breaking down the radical, I'm not going to like take off 10 points because you can't break down a radical, because for most of you it's new. Okay, so now we're going to take 60 What makes 60? Okay, now I heard different things. I heard 10 and 6. I heard 12 and 5. You can use whichever one you want. I'm going to use 10 and 6. 2 and 3. 2 and 5. What's the only pair of things that I have? A pair of 2s. Okay, so I'm going to group them together. That goes one time on the outside. The 5 and the 3 are left, so they're going to go inside. So that just became 2 radical 15. 2 square root 15, whichever way you want to say it. So I know that this square root of 60 is really 2 square root of 15. So I have 12 plus or minus 2 square root of 15 all over 6. Can you reduce that? What are you thinking, Brianna? By 2, right? Everything on the outside, here, here, and here, all by 2. Excellent. Go ahead and do that. Because we had multiple things to come outside. Over here, I only had one thing to come outside. So we get x. Don't forget your x equals on there. 6 plus or minus. You can put the 1 there, but you don't have to. It's going to mean the same thing. Over 3. 6 plus or minus the square root of 15 over 3. If you put a 1 here, that's okay. It means the same thing with or without it. Box your answer. Give your neighbor a high five.
High five neighbor.
Colt, looking for a high five. Tracy, did you get a high five?
I'm not home.
What? I said Colt. Oh. All right. Let's take a break.